Hello, everybody, and welcome to Technology Today for June 1st, 2025. Wow. My brain. Anyway, it's season 2, episode 22. I'm Merwatt. I run ohmTown.com. My brain's a little frazzled today. Sentient AI isn't here. We're going to talk about 5 articles, multiple robots on the moon, most efficient solar cell, water treatment challenges, showstopper galaxy, and geopolymer technology. That and more. Powered by ohmTown.com. It's a news aggregation site. Doesn't have any ads. Doesn't cost anything for you to access. Go over, sign up, check it out. Come and hang out with me and the Sentient AI every day, 7 p.m. Eastern. Usually mayoral duties kept me busy this weekend. Will definitely be impacting me next weekend as well. That's okay, though. It's the summer of stream. All right. Let's get into this. I am in a time machine. This is the front page of ohmTown.com. I have to get through this so that I can get back to the future. This is the front page of Technology Today, and this is the current logo. We're going to be changing those. I've been saying that for every episode that we've done, or that I'm doing in the time machine today. So, multiple robots on the moon, huh? So there's a challenge of coordinating multiple robots on the moon. Frameworks are a critical, if underappreciated, component of any space exploration mission, and they can range from all over mission architecture, capturing scientific and technical data, goals, to the structure of messages sent between 2 internal components of a system. Well, this article is over at techexplore.com. Andy Tomaszwick from Universe Today put the article together. It's edited by Sadie Harley and reviewed by Andrew Zenon. One of the most interesting frameworks that is getting much attention in the space exploration community is the interaction of multiple robots for a single purpose, known as a multiple robot system, or MRS. On top of that, one of the most common frameworks for robots on Earth or in space is the open source robot operating system, emphasis on the wrong syllable. Anyway, ROS, which is commonly used to run everything from vacuum cleaners to giant mining trucks. In most recent iteration, ROS 2 even uses yet another framework known as middleware to handle aspects of robot communication such as networking and packetizing data. However, there are plenty of different middlewares to choose from for ROS, so a team of researchers from the University of Luxembourg decided to try to pick one that would best suit planetary exploration applications. I think it needs to be fast and freaking reliable and according to a mesh, basically. The most likely candidate for such solution is a networking system known as a mesh network. A traditional network has a central hub with all of the different sub-nodes talking to it, which handles the data-intensive processing and interfaces necessary to keep the network operating. On the other hand, a mesh network allows each node to talk to each one another, actually, without needing a central hub, and it has many advantages. It's much more like the internet, where if something happens that's catastrophic to the internet, data can wrap around. If the internet weren't being dicked around with by people that have an objective other than stability. Yeah. Anyway, so if one of the nodes goes down, the flexibility of finding the fastest way to get the data from one node to another is its objective in a mesh network. However, it does have the disadvantage of being computationally more intensive for each individual node and laggy compared to more, because basically the packet has to get somewhere. It has to be verified. That verification has to be sent back to the sending node so that everybody knows that everybody has got a packet, but only one destination location has received the packet with priority. But given the challenges in the network that a moving set of robots would experience while exploring extraterrestrial worlds, meshing seems like the best strategy. So in the Journal of Intelligent and Robotic Systems paper, the researchers decided to examine 3 different ROS middlewares to see how they would handle a mesh network similar to one that they would do on a lunar mission. So The 3 middlewares were FastDDS, the most common default middleware, Cyclone DDS, which specializes in sending large messages, and Xeno, which specializes in dealing with unstable networks. I think they probably need a little bit of all of it. It needs to be fast. It needs to send large packets so that it can transfer large amounts of information, obviously, in a single go. And unstable basically is space. So we need the reliability and the success and speed. So I think it all works together. Maybe composite those together. Measuring the performance of each middleware would involve calculating 5 variables: whether or not all the robots were reached, how much overhead the network utilizes, and how long it takes for a message to reach its intended target, and the overall utilization of the CPU on the robot and RAM. So overall, the experiment described in the paper is a step toward coordinating robots that work in concert on another world. Let's keep going. The next article is over in Technology Today. International research team builds world's most efficient organic solar cell. I don't really like anything organic in technology because it's going to keep breaking down at a rate that's different. It's kind of like what happened with DVDs, Blu-rays. They broke down over time because they were organic. Scientists created a safer, high-efficiency, all-organic solar cell using a new electrode and lamination technique, achieving 8.7% power conversion, more than double past models. As global initiatives to mitigate climate change accelerate, the demand for solar energy continues to rise. However, conventional silicon-based solar panels, which currently dominate the market, contain a variety of hazardous materials. They're a nightmare to recycle. Kanazawa University over at SciTechDaily.com put the article together. Yeah, similar concerns apply to emerging film-type solar technologies such as perovskite solar cells. Although promising in performance, these next-generation cells also incorporate potentially toxic components, including lead compounds, metal oxides, raising further concern about long-term stability, sustainability, and safe disposal. The all-organic solar cell, despite their environmental advantages, all-organic solar cells currently suffer from low power conversion efficiency, or PCE, reaching only about 4%, but this new one reached 8.7%, significantly lower than the greater than 27% for silicon and 26% for advanced perovskite cells. But those are silicon have a lot of toxic issues, and perovskite is hard. The material necessary to make it is difficult now. So they found a breakthrough in an all-organic solar cell efficiency system. Masahiro Nakano, associate professor from Institute of Science and Engineering, Faculty of Chemistry at Kanazawa University, has collaborated with scientists from Raiko Company Limited, Junichi Iwa, president, and Queen's University in Kingston, Canada, and now successfully developed all-organic solar cells with the world's highest efficiency. Great. Organic electrode ink. Okay. I don't know. This is going to be kind of hard. It had 2 major problems that previously hindered the performance of all organic solar cells. First, the availability of highly conductive organic transparent electrode material suitable for film-type solar cells is limited, and some high-conductivity organic materials have been reported, but their preparation requires strong acids, bases, or high-temperature annealing, which would damage organic substrates. So heat is the bane of everything, and in a solar cell, it's generating heat in and of itself, just sitting there baking in the sun. The second challenge lies in stacking multiple layers within the film-type solar cell device without harming the layers underneath. In solution-based processes, the ink used for the upper layers can damage the underlying ones, and to address this, the researchers developed a lamination method using a carbon nanotube electrode, which allows for the addition of layers without compromising the integrity of those below. So combined, they figured out a way to raise the efficiency to 8.7%. All right, the next article is over in Technology Today as well. Next generation materials offer integrated solutions to water treatment plants. This article is over at Tech Explorer. It's written by the National Research Council of Science and Technology, but edited by Sadie Harley and reviewed by Robert Egan. This new purification process removes harmful substances, including phosphorus, which causes green algae and disinfects microorganisms such as total coliform. Phosphorus is an essential component in domestic and industrial waste, including fertilizers, detergents, animal manure, but when it remains in the water, it causes algae blooms in rivers and lakes that you're used to. But this actually causes issues in whatchamacallit, aquaponics, hydroponics. So a research team led by Dr. Jae Woo Choi and Dr. Kyun-jin Cho of the Center for Water Cycle Research at the Korea Institute of Science and Technology, KIST, K-I-S-T, has developed a new water treatment material that can recover phosphorus in a short time with high efficiency and disinfect harmful microorganisms at the same time. The work was published in the journal Advanced Composites and Hybrid Materials. So the team utilized a sea urchin-shaped nanostructure to achieve world-class phosphorus recovery performance, and the developed material can recover about 1.1 kilogram of phosphate per kilogram of material in just 5 minutes, which is extremely fast and efficient compared to existing technologies. The new materials and technology developed are applicable to a variety of water treatment environments, including sewage treatment plants, water purification plants, livestock, and industrial wastewater treatment sites. In particular, it's possible to simultaneously remove algae-causing substances and recover resources at industrial and agricultural sites with high concentrations of nutrients such as phosphorus. Brilliant. So it can stop runoff if all of the runoff is captured. Let's keep going, though. The next article is over in Technology Today. This galaxy is a showstopper, but the real twist is nearby. I'm going to go straight on over to the source. ESA Hubble put the article together. It's posted over at scitechdaily.com. So taking stage is in the Hubble Space Telescope image is a stunning spiral galaxy called NGC 3507, located about 46 million light years away in the constellation Leo. The celestial beauty is classified as a barred spiral galaxy. Its graceful arms don't spiral out from the center as you might expect. Instead, they stretch from the ends of a bright central bar made of stars, giving it a distinct and eye-catching structure. Dun-dun. So I guess right there. This is one bright ass star right there. Anyway, NGC 3705, a spiral beauty in the Leo constellation, steals the spotlight while its galactic partner remains just out of frame in the stunning. Just out of frame. So where is it? Okay. So although it looks like a solo act here, NGC 35 is actually part of a galactic pair. Its companion, NGC 3501, lies just outside the frame of the image and appears in a previous Hubble feature. See below. I don't know. What, down here? So this is really fascinating because there is a dark band that goes through the width of our galaxy, but it's all of this dust inside here, inside the core basically of our galaxy, is causing stars to be obscured. And using new astronomy technology, you can peer through it, and there are millions of stars inside this one galaxy, in our galaxy. It is amazing the hubris that people have to think that we are the only thing out here. Anyway, we're just too dumb to actually be able to find anything else. So for galaxies that are just a few tens of millions of light years away, NGC 3501 and NGC 3507 features like spiral arms, dusty gas clouds, and brilliant star clusters are on full display. More distant galaxies appear less detailed. So in addition to these far-flung companions, NGC 3507 is joined by a far nearer object marked by 4 spikes of a light, a star within the Milky Way, a mere 436 light years away from Earth. Now, that's a long distance, folks. But all of this is getting cut back dramatically in the hopes of saving money. But we'll see. We will see. Yeah, I don't know. I think that there's going to be a tremendous amount of damage done in the people that are chomping at the bit to stop spending or not even paying attention to everything that's taking place. Equipped with powerful cameras and spectrographs, the Hubble has helped measure the expansion rate of the cosmos, revealed the existence of dark matter or dark energy, and inspired both scientists and public with its breathtaking views of deep space. But can't even get into it. Anyway, astronomers use an instrument called spectrometers to split the light from these distant galaxies to study the nature of these objects in the early universe. This is a neat article and has some amazing pictures. Let's keep going to the next article, and this is the last one for today's Technology Today. Geopolymer technology turns recycled glass and construction waste into a durable and green construction material. With global population growth accelerating urban expansion, construction activity has reached unprecedented levels, placing immense pressure on both natural resources as well as the environment. So the cornerstone of modern day infrastructure, ordinary Portland cement, remains the most effective and commonly used soil solidifier, despite contributing substantially to global carbon emissions. So this article is over at techexplore.com, written by Shibura Institute of Technology, edited by Gabby Clark, and reviewed by Robert Egan. So alkaline stimulant, also referred to as earth silica, apparently allows for construction waste to be turned into durable and green construction material instead of using Portland cement. So at the same time, construction waste continues to accumulate in landfills, along with this issue about Portland cement. To tackle these interconnected challenges, scientists from Japan, led by Professor Shinya Inazumi from the College of Engineering, Shibura Institute of Technology, Japan, present a sustainable alternative, a high-performance geopolymer-based soil solidifier developed from siding cut powder, a construction waste byproduct, and earth silica sourced from recycled glass. This breakthrough innovation offers an alternative to reducing cement dependence while transforming construction waste into valuable construction resources. The paper is published in the Cleaner Engineering and Technology Journal. What? Trying to save the planet? So there's a quote here. This research represents a significant breakthrough in sustainable construction materials. By using two industrial waste products, they develop a soil solidifier that not only meets industry standards, but also helps address the dual challenges of construction waste and carbon emissions. They say a noteworthy aspect of the study was the approach to environmental safety. The solution offers numerous practical applications with wide-reaching real-world impact. I want to see the strength data of this thing. The findings point to transformative shift in sustainable construction practices, potentially transforming millions of tons of construction waste into valuable resources while reducing the carbon footprint. The recycling needs to be cheaper than just digging out the planet, and that just doesn't work because you have to basically undo all of the contaminants from whatever it is you're trying to recycle, and it's not an easy thing to do. We work hard to contaminate all of the other stuff that we're trying to save. I know, it's weird. So we're going to mix a couple of geopolymers, and that's going to solidify our position here at the Technology Today front page over at ohmTown.com. But that means I am done. I've got to get out of here. The time machine is going to overheat. So I'll see you in a little bit, and be sure to click all of the links that are in the show notes over on YouTube and then in the podcast episodes. See y'all soon. Bye-bye. Oh, and don't forget, there is a podcast, there's a Discord, there's a Patreon, YouTube, ohmTown itself, and here on Twitch. We're all over the place. So see you in a little bit. Bye-bye.